So let's talk about a spatial curiosity called, oh, that is how you spell curiosity. Called the cross product.
There's no U in curiosity.
What's that?
There's no U in curiosity. Stop. What? Oh, no. Okay.
Okay, good talk.
Yep.
So, I still don't know how to spell, we've established that. It also doesn't matter, because the important thing is that I can spell cross product.
Yes. I was gonna call you out this morning on Discord about it. I wrote up a whole thing and I was like, that's too mean.
Yeah, I'm not worried about it, I know I have limitations. Spelling is one of them. So, the cross product is a way to multiply vectors that's not the dot product. It's also, it's a spatial curiosity in that it only exists in R3. So, don't get too attached to this thing, because it only works in one place. The one place it works is handy enough. Yeah, so we're going to talk about it. It is symbolically a determinant, but why it's a determinant is kind of left for grabs. So I'm just going to teach you to calculate the silly thing. So you're going to take two 3 vectors, u cross v. I'm going to write this as multiplication, right, a la grade school. Please note, the only places you should use X's like this are when you're at the hardware store looking for 2x4s, or when you're doing cross products. These two vectors need to be 3 by 1. Or at least they need to be 3 vectors. I'm going to pretend for a lot of this that they're rows. So I'm going to take my vector u1, u2, u3, and we're going to cross that with the vector v1, v2, v3. And the way I'm going to do this is I'm going to define I'm defining the multiplication symbol here, right? And it's going to be the determinant of the matrix I, j, and k across the top, and then put u in this second row and v in the third. You guys good with this as a procedure? Okay.
What's I, J, and K?
Yeah, so this is why it's symbolic. It is not actually a determinant, it is only symbolically a determinant, because it doesn't make any sense for me to have a matrix where the sum of the entries are numbers, like u1, u2, and v, the u's and the v's, and then some of the entries are vectors. So by I, j, and k, I mean these standard basis vectors in R3. So this is the vector 1, 0, 0, this is the vector 0, 1, 0, and this is the vector 0, 0, 1. So when you do this calculation, you will get I times the determinant of its little cofactor. What's its little cofactor here?
U2, U3, V2,
U2, U3, V2, V3. That U looks suspicious. Good. Right. First row, first column. Cover it up. Everything that's left. And then we have to remember to subtract J. And here we'll have our little cofactor, and that little cofactor is going to be U1, U3, V1, V3. And then we'll add to this K, and here we'll have our little cofactor for K, which is going to be, what's the little cofactor for K?
U1, U2, V1, V2?
U1, U2, V1, V2? Okay. I mean, that seems like a thing, I guess, right? Probably. I don't know. Maybe.
You guys have done
I guess I get some stuff. Sure. Right? It's like,
Oh, this is just.
seems like a pretty stupid procedure, frankly, right?
You guys
like-
have done torque, right?
Now?
Oh, they're
Cool,
just getting
good.
into it. The cross
For-
product is used for torque.
Yeah, but forget that shit.
Okay, never mind then. Whatever.
No, I mean, you can do physics if you want. It has 3 properties which are very convenient.
You're shitting on physics, I see how it is.
So this is where the students who have had Calc 3 get to show off that they remember things. So what is it that you remember from Calc 3 that's true about the cross product?
Perpendicular to those guys.
Okay, so U cross V is perpendicular to U, and it's also U cross V is also perpendicular to V. I suppose I should note, what kind of thing is this? Like, what's the result you get out of this? Like, you're gonna get something, right? But what is all
Those
this?
are entries of a
You guys see that? They're not entries of a vector
vector.
quite.
Like, I mean, you know the.
Yeah, the whole thing is a vector.
Yeah, the components.
You guys see that? So this is a vector in R3. So I started with 2 vectors in R3, and I did some weird-ass multiplication, and I got another vector in R3. And what's cool about that vector is that it's perpendicular to both the things you start with. You can use a dot product to check that that's true. What else? Close, not tangent.
It's the normal.
It's normal to a plane formed by the 2 vectors. That's just this. But that's what we're going to use it for in Calc 3, right? If you've got a plane,
Yeah.
you can snap a handle onto it by the one vector that sticks straight out of it, and then you can torque it around by pulling on the handle.
You just used physics.
You guys see that?
Yeah, you just said torque. Yeah, come on.
Yeah, but I didn't say it in the way that you mean it.
But you just did. Might as well with like a QE.
Okay.
I'm done.
Alright, second thing. What else?
If the cross product results in 0, then the 2 vectors are parallel.
Okay, that's useful. I'm going to put that as bonus.
Do you want like A, B, sine, theta? Is that what you want?
Close. Yeah, so there's this characterization that the magnitude of U cross V is the magnitude of U times the magnitude of V times the sine of the angle in between the 2 vectors. This is not, like, I don't really care if you remember this formula. I want you to think about this as it's the area of the parallelogram formed by U and V. You guys with me? Okay, so it's perpendicular to both the things you started with. It's as long as the parallelogram is big. And is that enough? There's one more thing because I labeled 3. And what was the bonus thing? I forgot.
They're parallel.
Oh, yes. So U cross, if U cross V is the 0 vector, then U is parallel to V. Great. What else? You just let the whole class walk by and now you get panicked by one person? You're fine. Catherine v. Sketch. Alright, what's 3? So I'm not expecting you guys to know. I'm expecting the students who have had Calc 3 to know.
Shouldn't like 4.
Shit.
Like 6.
Okay, so think about it, right? I've got a vector I've got U and V, right? I've got a vector that's perpendicular to that thing, and I've determined the length.
Yep.
What is it that I haven't determined?
So the magnitude
direction.
of the cross product is the area inside the parallelogram.
Yes, that's this.
Wait, but the direction.
Yeah, I haven't determined whether it sticks out of the board or into the board.
If one of them are 0.
No.
So you gotta do the right hand.
Yeah, follows the right hand rule.
Where's our shield for the right hand rule?
Alright, so it's wow. So it's
So the
you bitch, fuck you, and this is the velocity.
Yeah.
This is where you run
no,
towards that.
stop.
Oh, what?
So the right hand rule goes, if you're taking U crossed V, you put your fingers through U first and then into V, and your thumb points in the direction of U crossed V. You guys see that? That means that if I do U crossed V, it sticks out of the board, and if I do V crossed U, it sticks into the board. Yeah,
You use it in physics.
yeah.
You'll use it everywhere all the time.
Yeah, this should be one of those, like, wait, why did that get so convenient? We can see some of these things right away now that we're in linear algebra class and not in Calc 3. So one of the things I can see right away is that this thing should be perpendicular. You see why?
What thing?
So how can I see perpendicularity here using the determinant? If you dot that thing with a vector, right? Like if you dot the result here with the vector u1, u2, u3, right? That's going to be you taking this first component and multiplying by u1, the second component multiplying by u2, and the third component multiplying by u3, right? Notice that's taking the determinant of this matrix again, where I replace the I, J, and K with U.
Oh.
You guys see that? The determinant of that matrix is gonna be 0
Yeah,
because it has two identical rows.
Yo, that's crazy.
You guys see that? Same with V. So I get that fact for free because I'm in a linear algebra class, whereas in Calc 3 I just told you that was the way it was and you believed me,
Well, it is.
right?
It
It
is.
is because it is.
It is because.
You guys see that? We actually checked it in Calc 3 by just taking the dot product, but now you can understand why the dot product obviously gives you 0. You see that? Okay, cool. There is a useful thing too, which is that if you take 3 vectors in R3 and cross 2 of them and then dot the result with the third one, it gives you the volume of the parallel pipette. You know what a parallel pipette is?
It's the parallelogram 3D guy. It's like a wannabe cube.
Yeah, it's a wannabe cube. It's what happens if you take a cube and smush it.
It's like the cube's deformed.
So a parallel pipette is this thing.
You should probably draw like triangle.
Box but smushed. Smoosh box? It's just it's the 3-dimensional analog of a parallelogram. Right? In the same way that if you take a rectangle, right? And then you push on this corner of it, it'll become a thisogram. Right? This is what happens if you push on 2 corners of a like rectangular box. Cool? So the area of the base is the area of the parallelogram formed by the 2 things. And then the altitude, you could figure out using some trigonometry and some mag A, mag B, cosine thing. It's in the homework. Hint. Look for the height. It'll get you there.
Rosie wants to know the height.
No. Find it out yourself. I will say that the drawing this pair of vectors is helpful. If you take the height from in the thing and scoot it over here, then this angle becomes a lot more useful. Just saying. Yeah. Big brain time. Sort it out. I want you guys to fiddle with that a little bit because it's really cool. And it's not anything more advanced than like some trig and knowing some formulas.
So this is like when you have your two vectors that you crossed.
Oh yeah, so let me write down the formula so you can have a little more in. So if this is say U and that's V and this is W, then the volume of the parallel pipette formed by U, V, and W is up to sine, right? Rosie, quit. W dotted with U crossed with V. Does that make sense?
Well, V is perpendicular to U.
V is perpendicular. No. Sorry, that's the altitude. V is the vector in the back. That vector. Well, that's a good quiet, Rosie girl. Good quiet. I know, parallel pipettes are scary. They're so scary. They require you to remember all sorts of trig formulas. You really don't actually need all sorts. You need the all sorts of trig formulas you want are this one and the one for A dot B. You guys got that. It's actually pretty cool. Do keep in mind that you'll end up with two thetas in there if you just use the formulas as stated, and the thetas in there would have different meaning. This one's the angle between U and V. And the other one is the angle between the cross product and the vector W.